C'est ça, un peu fait Postgres. Là, j'essaie de regarder cette vidéo. Et puis, disons, il y a aussi ce tutoriel, mais je ne vais pas trop aller en profondeur dans ça pour l'instant. Donc, on va plus ou moins commencer pas à pas. Et puis, on va voir ça. On va voir des pratiques qui sont intéressantes. Donc, on va plus ou moins regarder cette vidéo. Et ça serait tout pour Postgres. Et puis, on va continuer avec, je sais pas trop, mais ça va dépendre de moi. Donc, mais pour aujourd'hui, on va regarder cette vidéo et aussi pratiquer un peu de Postgres en parallèle. Donc, c'est un peu ça pour le live d'aujourd'hui.
To do a crash course on Postgres, the most popular, the most widely used database management system out there. It's a relational database management system. And I think that for a channel that focuses a lot on machine learning, a lot on artificial intelligence, data science, databases are like kind of the foundation. You need to know how to work with databases. So I think a lot of people maybe know how to program in Python, maybe know how to even build agentic workflows, but if you miss the database basics, that's not good. So today we're going to cover them. If you like this video, let me know by hitting the like button and subscribing. And now let us get right into it. All right, so we're going to do a crash course on Postgres today. Now, as you probably already hear it, my voice is a little bit scuffed today. It's because I have a cold or allergies or something. I hope this doesn't distract you too much, but you can prepare for an occasional voice crack here. So Postgres is the most popular, arguably the most popular relational database management system. You could say it's the most mainstream one. When you start a new project and you need a database, you either go with Postgres usually, or you go with SQLite if it has to be very lightweight and you don't really need a lot of features. But Postgres is the go-to choice. It's the default choice. And I think there's multiple reasons for that. One of the reasons is it's open source, free to use. You can use it in every project without having to pay anything. Another reason would be it's super simple to get started with. It's beginner friendly. Also, one of the major reasons, in my opinion, is it has a ton of features. It's super extensible. Oftentimes, new databases are released that have specific features, and a couple of months later, you get powerful Postgres extensions where basically Postgres becomes like that database. An example would be PG Vector. Oftentimes you don't need a separate vector store. You can just use PG Vector. Now you have a column in your database that's a vector. And also, of course, Postgres is quite old already, so people just trust it. But we're not going to talk too much about the theory here. Let's get right into it. I think if you're learning databases, Postgres is probably the best way to get started. So we're going to make a crash course on this today. And let us start with the installation. How you install this, of course, depends highly on your operating system. If you go to postgres.org or postgresql.org/download, you will find the different installers. For Linux users, I recommend you use your package manager. If you want to install it locally, these are all local installs. In this video today, I'm going to install a Docker version. If you're not familiar with Docker, if Docker scares you, if you don't want to use Docker, no worries, you don't have to use Docker in this video today. I'm going to show the setup. If you're not using Docker, just skip it, install it normally, use it on your system. If you want to use Docker, just follow the steps. The reason I'm using it is because it's just easy to set up and I don't want to install Postgres on my system. But just choose the operating system that you're using, choose the package manager that you're using, and install Postgres onto your system. So if you want to go the Docker route, pick a directory on your system. In my case, I'm going to go with the tutorial directory and create a new file called docker-compose-yaml. So of course, this assumes you have Docker set up on your system. Again, you don't have to do it. I'm not going to cover it here. I do have a Docker crash course if you want to take a look at it, but no necessity to use Docker here. If, however, you're using it, we're going to start with services and we're going to write the Postgres service. Postgres will be based on an image of Postgres. So we specify here Postgres-17. Actually not dash colon. Then we choose a container name. Let's call the container PG-tutorial. And then we set the environment variables that are just going to be our username and password. So we're going to say Postgres_user is going to be equal to Postgres, then Postgres_password is also going to be Postgres. Of course, in production, you want to change this to actual reasonable values. And then Postgres_DB, it's automatically going to create a tutorial database. So let's just call this tutorial here. Then, of course, in order to be able to use this locally, we want to map the ports. Postgres is running on the port 5432, so we want to map this to the local port 5432, like this. And important, if you want to persist what you're doing, we're going to say volumes, and we need to define a Docker volume down below then, and say that the Postgres database that we're working on should be stored even if the container vanishes. So I'm going to call this one pg data, and we're going to map var or /var /lib /postgresql /data. Now, an extra thing as also and we're going to call this, for example, admin at example.com, and then pg admin v, then say docker compose up. This is enough to initialize or to run and then initialize the Postgres database or Postgres server with the database, and also pgadmin. All right, and just to be clear what we're doing here, pgadmin is listening on port 80, and we mapped it to be on port 5050 just because 80 is oftentimes taken and we're using 80 for something else. So what we have to do now to access pgadmin is we have to go to localhost 5050. So localhost 5050 in your browser, and this is going to take you to the pgadmin web interface. Here now we can just enter the email we defined as an environment variable, so admin. To access pgadmin is we have to go to localhost 5050. So localhost 5050. In your browser, and this is going to take you to the pgadmin web interface. Here now we can just enter the email we defined as an environment variable, so admin at example.com, and the password is admin. Now we're going to take a look at two tools to interact with our database. One is pgadmin. This is the user interface where you can click and look at stuff, and then we also have the command line tool, which is psql. Now, in order to have psql on your system or psql on your system, what you need to have is you need to have either Postgres installed, then you have the tool automatically, or you have to install at least a library that gives you this tool. So if you're going with the Docker Compose setup where you have pgadmin and you have a Postgres running via Docker Compose, then you can do two things. You can go into the container itself. So we can go to the tutorial directory again, and here I can say Docker Compose exec, and then I can go into Postgres and run bash, and then here I can use PSQL. That is a possibility. I can just connect to localhost and use the tool from within the container, or you have to install the package that gives you the PSQL or pSQL command line tool on your system. So in my case, I use pacman for this on Arch Linux, pacman-s, and the package was called, let me find it here in my prepared notes, Postgres or PostgreSQL-libs. So this gives you not Postgres as a whole, but just the libraries that contain also the CLI tool. So we're going to take a look at both, but first of all, let me show you pgadmin, then we're going to also take a look at the command line. pgadmin is now the management tool here that we can do everything in a visual way in. And the first thing we want to do is we want to connect to the server. So right now we have no server here, and we want to add a new server. And I'm going to talk about the terminology in a second here. What is a server? What is a database? What is a schema? What is a table? But for now, let's just accept that there is a server. That is our running Postgres instance, or Postgres instance that is running. And we're going to connect to it by first giving it a name. Let's say tutorial server or something like this. And then in connection, we have to specify now how we want to connect. Now, keep in mind, we're connecting here from within a Docker network. So in my case, since I'm running the Docker setup, I have to provide the host name of the Postgres instance within this container. If you're running this locally on your system, you would go with localhost. Since I'm not running this on my system locally, but in Docker, I need to say Postgres because this is what my container is called, or my container basically. So Postgres is the host of this thing, and then I have the username also being Postgres, the password also being Postgres, and the database is tutorial. So I can just save this here, and this now starts a connection with my tutorial server. So again, if you're not sure what you have to enter, go to your Docker Compose setup. If you used one, take a look at the Docker Compose file. In here you have the username, the password, the database. This is what we entered, and this here, Postgres, is the host. This is the thing that it is called in the network. If you're running this on a server, you provide the IP address. If you're running this locally, you provide the local. If you might confuse you, you can ignore basically all of it for now. We're going to focus on the essentials. We have a server. The server is our running. Now, a server can have databases. A database is just a way or a place to store data in an organized way. We can retrieve data, we can save data, we can do stuff with data in an organized and structured way. This is what a database is. And we have the Postgres database by default, and we have the tutorial database that we created by providing the environment variable that had the name. Now, in a database, you have a bunch of stuff, extensions, languages, publications, whatever. The important thing for us now is schemas. And a schema is basically a collection of tables, views, and a bunch of stuff that you don't know about yet. Triggers, for example, trigger functions, sequences, whatever. A schema contains all of this. And we can have multiple schemas. Schemas are usually focused namespaces, you could say. You have user schemas, you have post schemas in a blog, for example, order schemas in e-commerce. So you have different tables and views and triggers that relate to user management, different tables, triggers, and stuff that relates to blog posts, for example. And in schemas, the thing that we're going to focus on in this crash course are the tables. And tables are basically just structures, you could say, where we store data using rows and columns. So if you have a people table, for example, you would have the columns name, age, occupation, gender, whatever, and then the rows would be the individual people. So Mike, male, 30, programmer, something like this. So this is what a table is, and multiple tables make up, or not just multiple tables, but multiple tables in combination with all the other stuff that you don't know about yet, makes up a schema. Schemas, you can have multiple of those in a database, and you can have multiple databases in a server. So that's enough of the theory now. Let's go ahead and do something. Let's create a table, for example. So for this, let's go and right-click here to Query Tool. So right-click Tables, go to Query Tool. There's also different ways to get there. And now we can just write stuff. And to write stuff, you need to write it in SQL, in SQL, structured query language. And one very simple thing that we could do is we could create a table for people. So I can say create. This is literally like English. Maybe I can zoom in a little bit so you can see this better, even though it doesn't look that good. Create table is just English. And the next thing is, what is the name of the table? The name of the table is people. And what I define next is I define all the columns. So create table people, then I use parentheses. I always have to close a command or end a command, a statement, by using a semicolon. And in here now I can provide the columns. So I can say every person has a name. Now the question is, what is a name? Or maybe let's call this person name because name is a reserved keyword. Person name. Or maybe let's do it like this. We're going to say first name and last name. And the question is, what is a first name? A first name is a string, a text, whatever you want to call this. In SQL, we say this is a variable character, a varchar, and we can provide a length. So let's go with 255. Now, there is also char if you don't want to have it variable. This is just less flexible in terms of memory. But here we're going to go with varchar 255. That's enough for a first name. And I can also provide certain constraints. But for now, we're going to keep it like this. We have a first name, which is a text value. Then what I do is I provide a comma, and I say I also want to have, let's copy this, a last name. A last name is also going to be of the text type. Then maybe I want to have an age, That could be an integer. Then I could say I want to have a job. This could also be a variable character, 255. And then I might want to also say if the person is employed or not, which is not a very intelligent thing to choose here, but let's say employed is a Boolean. Now, one thing that we also want to add here is something called a primary key. And the primary key is the column that we use to identify individual users. So I can have a person with the same first name, last name, age, job, and employment status, but that doesn't mean that it's the same person. And to distinguish the people, I need a column that is unique, not null, so it has to always be set, it's always unique, and it has to be the identifier, which we can call ID here, and I can say ID is an integer. In this case, it's just going to be a number, and I can say primary key. This is going to make this the identifier of this table. So that is the most simple thing that we can do. And I can now just go ahead and execute this script by clicking this button, pressing this button, and you can see down here, query returned successfully in 54 milliseconds. So when I zoom out a bit again, we can see now if I uncollapse the tables, hopefully I don't see it right now, but I have to probably right click and refresh. And then if I go back to tables, we can see that we now have a people table and I have columns. So if I uncollapse the columns, we can see the different columns here. I can also right click the table, go to properties, and see everything here in a GUI interface. So I don't even have to type create table. I can just go and edit the stuff here myself. I don't need SQL commands to do that in pgadmin. But of course, what we're trying to learn today is SQL and Postgres as a database management system. So we're not going to use mainly GUI tools. We're going to type everything manually. And now this is our table for people. What happens if I try to run this command again? If I just execute the same script again, I'm going to get an error. Relation people already exists. But sometimes I like to have a script that I run from top to bottom, and I want to keep the command in there. So what can I do here? I can use plain English. I can say create a table if not exists people. So create this table if it doesn't exist, otherwise just skip this. So I can run this and you can see already exists, skipping, create table, worked. Now, what we can do with this table is empty. And if I want to see that this table is empty, I can use a so-called select command. There is a select command or a select statement in SQL that basically says select, then you choose the columns. If you want to choose all the columns, you use an asterisk. So this symbol here, so maybe we can maximize first so you can actually see the code primarily. If I say here select everything, from is the second keyword. So I say select everything from a certain table. people, then I use a semicolon, then I zoom out again and I run this. I have to, of course, minimize to see the result. Then you can see I get the columns, but I get no data because our table is empty. We don't have anything in our table. So selecting everything from the table gives us the structure of the table, but no content. So then, of course, we have another statement, which is the insert statement. Insert into tells us or allows us to insert data into a specific table. So insert into people, and then I can say values, and I can provide in parentheses individual rows. So I can say in the right order, ID would be 1, for example, first name would be Mike, second name would be Smith, age could be 30, job could be programmer, and then true would be the Boolean, the employment status. So this here is an insert statement. I can run only this statement by using this second execute query button. This only executes then the insert statement, not the entire script. And you can see now something was inserted. I can go and run the select statement now, and I have data in my table, which is Mike Smith, 30, programmer, true. So this is how we can do that. Now, before we go deeper into SQL and into the different statements that we can use, let me show you how we can also connect with a CLI tool. So not with pgadmin if you don't like the user interface. If you like to stay in the terminal, you can also use PSQL. So what do we need to do here? We need to just say -h and the host. Now, since we're connecting from the outside, since we're connecting from outside of the container, pgadmin is running inside another container, so we need to provide Postgres as the host. But I myself am connecting using PSQL to the Docker to the Docker Postgres instance where I have the port mapping. So I have to say localhost. And of course, if you're running Docker, if you're running Postgres without Docker on your system, you would also go with localhost. Then I say -U for the user. That's going to be Postgres. And then -D, which is going to be the database tutorial. I'm not providing a password because it's going to ask me for the password anyways. So here now I say Postgres, and now I'm connected using the CLI. And in the CLI now, I can do a bunch of stuff. I can run basic commands like \D to see all the relations, and DT to see all the tables, in this case the same output, but there's also other relations than just tables. We have views, for example. So here just \DT gives me the tables. I can also say -L to list the databases. Here I have Postgres, template 0, template 1, tutorial. And what I can also do in this command line, and by the way, if you want to clear the screen like I did it right now, you can just say \! and clear. This is going to run it as a Linux command. But what we can also do is we can just type SQL statements. I can say select everything from people, and we're connected to the same database, to the same server, so I can just run this and we'll get the data that I just inserted in pgadmin. And I can, of course, insert more data here using PSQL. So I can say insert into people, and I can say values. let's go with 2. Let's say Lisa, and then, I don't know, Woods or something like this. And then we can say that she is 45 and she has the job clerk, and we can say that she's employed as well. And then semicolon, this is also going to insert. Now if I run select, I can also see all the data in the database using the command line. And of course, if I go back to pgadmin and I just run this line here, I'm also going to see the new row in my table. So that is nice. Now, I'm going to mostly be coding here in pgadmin just because it's easier to understand for beginners when you have all the colors and everything. So I'm going to be working in this here. But again, everything I do here, you can also do in the PSQL command line tool. So let us go back to our script now. I'm going to maximize. And here now we can also look at a different way to insert values into a table. Because right now we're taking every single column and we're providing values. And these values, of course, can also be none. So I can, or null in SQL. So I can say ID 3. I can say it's another Mike, but he doesn't have a last name. So I can just say null, which is an empty value, basically non-existent value. I can also say he doesn't have an age. I can also say he doesn't have a job, but I can say he's employed, for example. That is possible. I can run this, and that's not a problem. We will see this entry in the database. If I minimize here, you can see we have Mike with null, null, null. So that's totally fine. However, this is not the best way to do that. What we can also do is we can specify the specific columns that we want to insert. So I can say insert into people, and then before I say values, I can use parentheses to specify columns. So ID is a must because I need to provide the primary key. I need to have a value for all columns that are defined to be not null, even though it doesn't say not null here specifically. It does say it implicitly by saying primary key, because primary keys cannot be null. So ID, first name, and then employed, for example, would also work. Then I can say value, and I can just provide 4, and let's say John, and let's say true. So these would be just 3 values, and I can run this, and this will also be inserted, values, of course, plural. This will also be inserted into the database. If I now select again, you will see it's the same effect as before, just that we didn't have to type null explicitly. And this also allows you, of course, to reorder the arguments. So you can say first name and then ID. So we can do first name ID employed. That is also a possibility. I can say it's Bob. He has the ID number 5, true, and I can remove the 4 here. So that is also not an issue. This is however we define it to be. The only thing is you need to provide the values that are not null. And if you want to see how to make something not null, you just go to the column and you type not null afterwards. So in this case, or actually let's do it also for the last name, you will see that this will lead to problems if I run a statement like this. So if I go and say that this is Chris, for example, ID number 6, and I run this, you will see that this will result in, it will of course exceed because we still have our table. So we need to first actually make the change. For this, what we can do is we can drop the table before we create it again. So I can say drop table people. Drop table people basically removes the table. Everything is gone. If I execute this, the table does no longer exist. So if I run the select statement here, you will see that I get an error message that this relation does not exist. So what I have to do is I have to create it again, now with the constraints not null. So I can run this, and this will create now a new table, and I can do the same command that I did before with this Mike null, 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 and you will see that this tells me failing row contains, because now the null value in a column which has a not null constraint. So the column last name has the constraint that it's not null, but we're passing, actually last name name, this is written in an odd way. So let me again drop the table and create it again, and then try to insert again. But now you see that this violates the not null constraint, and this as well. So if I run this, it will also give me a violation of the not null constraint because last name has to be set. Now, another thing that's interesting is that the ID always has to be specified manually. And it makes sense if the ID is something like an identifier that is a complex string, maybe has a structure in it, maybe it's randomized, but oftentimes the ID will just be an incremental number. So it would be 1, 2, 3, 4, 5, and so on for every new user. In this case, int is not the best type that you can choose here. We want to choose something called serial. And serial is the way that you define this in Postgres. and other database management systems, you oftentimes call this auto increment. It's a constraint or a separate property that we attach to the column. And this just basically means that you don't have to specifically provide the ID. You can just say that the ID is implicitly given by incrementing the ID of the last row. So I can run this, or actually let me run this and then this. And now I can just go ahead and insert into people without providing the ID. So I can just say insert into people, for example, first name and last name. Even though the ID is a primary key and thus not null, I can say that I have Mike Smith, for example, without all the other values. And when I run this now, the ID will implicitly be given. So if I select, you will see that this is, when I minimize, this is 1. And if I do it again, because we can't have duplicate names, I'm just going to go and run the same statement multiple times. Then you will see that the ID automatically just increases by 1. So 1, 2, 3. Again, this makes a lot of sense if you're using just a number. If you're not using something like a social security number, that is a good way to define the ID. And by the way, you don't have to always just insert an individual row. You can say Mike Smith, and then you can open another set of parentheses here using a comma. So I can say Mike Smith, I can say Lisa, what did I call her, Woods. Then maybe we can say Chris Stones or something like this, making up random names here. Executing this, selecting, and you will see that all of these end up in the database. So we can also do it in a batch. All right, so now we know how to create tables, how to populate them, so how to insert data into tables. We know how to select from tables. We also know how to drop tables. By the way, if you want to make this conditional, you can also say drop a table if it exists. This makes sense because you cannot drop a table if it doesn't exist. So you can just type it like this as well. But now we want to move further and say, how can we select specific rows of data? So right now we're selecting all the rows, we're selecting all the columns. Of course, we can also say select just the first name and the age. This is also possible. I can do that. In this case, the age is null because we didn't insert any ages. But that will give these columns. But what if I want to say...
Moi, c'est posé. On pourrait dire ça. Donc, c'est ça. Bon, il y a plein de trucs. Et toi, tu vis c'est dans la nuit. Bah, rien. C'est moi comment regarde le. Il est quelle heure? Il est 18h, pardon. Il est 18h, c'est donc, c'est toi qui vis la nuit. Bon, moi rien de spécialement, mes spams, c'est moi les bouts sont marqués, mes spams, mes Fiverr, non? Là, il est minuit 27, mais c'est ça, c'est la nuit. Tu veux bien profiter des congés, je vois ça. Alors, je sais pas, je peux te... Bon, bon. Ok.
In this case, the age is null because we didn't insert any ages, but that will give me just these columns. But what if I want to say, give me only the columns that have an age value of above 30? So how can I do filtering here? For this, let us actually add some data.
Hey. Ça. Mais là. Là, je prends ça. On va mettre ça ici. Ça, on va mettre ça. Bon. Vu qu'on a dit on n'est pas obligé. On n'est pas obligé de provide. Ça. Pareil. On n'est pas obligé. Ça serait... Bon, on met un dernier. J'oublie toujours que ça va pas prendre ça. Ok. Ici, ça dit quoi? Comment ça? Ici, on dit input syntax attack motion Python. C'est dont on peut pas le verbose. C'est vrai que je pars. Bon, si on veut. Mais je pense que c'est ça le problème. Ici, on laisse un edge. Yeah, on va d'abord drop ça. Puis on va run ça. On va insert ça. Si ça refuse. Insert interpret invalid import syntax or mais je sais pas que je suis obligé de mettre. Et si je mets. Ok. On va encore drop. On va adorer ça. Ok. Puis on va run ça. Là, on va adorer. Si on a l'erreur, on doit préciser ID. Puis c'est sûr que ça va mettre deux. Voilà. Sauvegarde. On a une erreur. C'est pas trop. C'est quoi l'erreur? Si ça dit quoi? Insert more expression that target machin. Colonne. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. Comment ça true n'est pas là? Ça c'est 1, 2, 3, 4, 5, 6. Oh shit, je suis oublié. Je dois pas mettre. Ok, là c'est bon. Et puis on peut run ici. duplicate ça ici déjà. Si je prends maintenant c'est l'école. C'est sélection.
Data that contains the age, so we're going to say Mike Smith, and I'm going to say that he is 30, then she here is 45, and this guy is, let's say, 80. So now we have a bunch of age values too. Let's drop the table, or let's mark all of this and execute this. There you go. So now I can select everything again, and we see we have Mike, Lisa, Chris, 30, 45, and 80. Now the question is, how can I get, for example, all the people older, or let's say younger than 50? Now, in this case, all I have to do is I have to take the select statement I already have, and I have to attach a where statement. So select first name, age from people, where, and now I can type a condition. I can say that the age has to be less than 50. So I write this like this, and I use a semicolon to run this statement, and as a result, I get only Mike and Lisa. I can also say has to be greater than 50. In this case, I would only get Chris. But also we can do filters that are not just for numbers. So for example, maybe I want to say that the last name has to start with an S. So how would I do this? I can do this by using the like keyword. So I can say where last underscore name like, and then I have to provide in quotation marks here the pattern. The pattern is I want to have an S and then whatever, which is a percentage sign. So S% basically means S and then whatever. If I do this, I will get all the people that have a last name starting with S, which is Mike Smith and Chris Stones, even if I don't show the last name in the query. If I want to show it, I can just say last name like this, and I will also get it here. And of course, I can combine all of these as well. So I can say I want the age to be less than 50 and the last name to be like S%. So this means I want to have only the people that are younger than 50 and have a last name starting with S. So now I can run this, and I will only get Mike. And if I'm interested in a logical or, not an and, I can also say or. In this case, I would get all of them because all of them are either younger than 50 or have a last name starting with S. So if I do this, I will get the full result set. Now, let us try something else. Let's say that I'm interested in the job of the people that have a certain age. And for this, I want to add the data and change the data. So I'm going to say here age and then job. And I'm going to say that Mike, for example, is going to be a programmer. Lisa this time is going to be an accountant. And then we're going to say that Chris is going to be also a programmer. And now instead of dropping the table, by the way, I can show you another thing. We can truncate a table. Truncating a table means that we're just emptying it. We're not removing the structure. We're not dropping the entire table. We're just truncating it. So I can say truncate table people. And if I run this now, this means that our data is gone. If I say select anything here, it's going to be an empty result set. So just like this, you will see there's no data, but the table still exists. So I don't need to create it again. I can just truncate it to empty it. And what I can do now is I can say I'm interested, or maybe for this, yeah, we can keep it like this. Doesn't really matter. Let's say I'm interested in the job of people. So select job from people where ages, let's say less than 100. All of them, whatever query you get, you will sometimes get duplicates. So get, of course, only after inserting the people again. But when I do this, you will see that we get duplicates. We get programmer, accountant, programmer. And since I'm not combining this here with a name, I get duplicate information, programmer and programmer. If I don't want that, what I can do is I can say distinct. Name, see that we get duplicates. We get programmer, accountant, programmer. And since I'm not combining this here with a name, I get duplicate information, programmer and programmer. If I don't want that, what I can do is I can say distinct. So I can say select distinct job from people where age is less than 100, and this will now give me every value only a single time. It will deduplicate the results. So accountant and programmer. Now I can also combine this now with the first name. So I can say select distinct job first name from people, and when I run this, you will see that now the deduplication does no longer work because now it's not the same statement anymore, or entry. It's not the same entry anymore because yes, it's programmer, but one is Chris, one is Mike. What else can we do? We can also do stuff like in between values. So I can say, let's remove the distinct again. Let's just go with first name and age. And I don't want to say that the age has to be less than 100. I want to say where the age is between, and I can say the age has to be between 32 and 67, for example. And when I do that, the only person that matches this description is Lisa with 40.
Ça veut dire qu'il y a pas de différence avec Postgres, parce que tout ça, je fais ça ailleurs. Ouais, je suis sur la documentation. Bon, on doit chercher juste un truc.
I can also say in and provide the values in parentheses.
Intéressant pour apprendre.
The result set will be the same because we don't have a clerk in the data set. Let's see if that's the case. There you go. But if I say programmer and accountant, then we're also going to get Lisa. And you can see we get Lisa as well. All right, so what do we know now? We know how to create tables, to drop tables, to empty tables, to insert data into tables.
On va regarder qu'est-ce qui serait bien. Parce que lui, bon, c'est quasiment la syntaxe de SQL qu'on a fait.
Of a row in the database. We can do that using the update statement. So I can say update and then a table name, people, and then what do I want to do? Set, for example, job equal to designer. And where do I want to do that? I want to do that where a certain condition is met. This can affect multiple rows. So if I say, for example, change the job to designer for every person that's less than 80 years old, then I'm going to change 2 rows here. If I say set job designer where ID is something, then I'm going to change a single row. So if I say that job is equal designer where the first name is equal to Lisa, then this is going to update that specific row. And if I now say, let's go with the select everything from people again, then you will see that Lisa now has a different job, which is designer. But as I said, if I say that, let's call programmer coder now, and I say that the last name here has to start with S, then this will affect the other 2. So if I say last name, like, and then S%, this will affect the other 2. So if I now run this, you will see we have designer, coder, coder. And finally, of course, we can not just add information, we can also remove information.
Ça, je fais update people set job profile. First name, like ça. Ici, c'est-à-dire j'oublie que je dois pas travailler avec les double quotes. Ok. C'est ça, je suis en train de savoir. C'est ça que je
go
vois.
ahead and say delete from people, and then I can say where. Again, condition can be multiple rows, affecting multiple rows, or just a single one. I can say where ID equals 4, I think was Mike in the output right now. So if I run this, we should be able to see that Mike is no longer part of the table. We only have Lisa and Chris. So delete from, and then a condition. This can again be 500 rows. This will just delete the entries. But now let's go back, truncate the table, and start again with the data that we have, because now I want to show you another keyword that we can use in combination with select, which is order by. We can order the outputs by a certain column. So if I say, give me everything from people, and then order by, and then I can say order by age. So if I do that, all the entries will be ordered by age. So I have 30, 45, 80. Now in this case, it's also ordered by ID, so maybe you don't see the effect. So let's go and say by age descending, DESC. This would reverse the order. So if I say by age descending, we would have 80, 40, 45, and 30. Now,
Comme ça, je faisais du SQL.
Job, this would be an alphabetic ordering. So now I would get accountant, programmer, programmer. And I can also order by 2 columns. So I can say first order by job, so I get accountant, programmer, programmer, but within the same job, order by age in reverse. So right now I have accountant and then programmer, programmer, but here
C'est comme intéressant, mais on
if
va
I want to
pas,
have 80, 30, I can say
on
order
va
by
pas éditer
job,
tout ça.
comma, age descending. And if I do this, we would get the reverse order for these 2. Another major statement is the group by statement. For this, I could say something like select job from people, group by job. This would not be a very useful query, but I can do that, and I would get just the jobs. But grouping makes most sense when you aggregate something. So for example, you cannot just say select job and then age. This would not work because you either have to aggregate or you have to group by. So in this case, you would get an error message. But what I can do is I can say, for example, count, which is an aggregation function, and I can just provide everything here, count asterisk. This would mean, give me for every job, how many people have this job. So if I execute this now, you would see accountant 1, programmer 2. Now, if I want to get a specific column involved, I can also provide it, but count doesn't make a lot of sense for age. So let's go with something like AVG for average. This would give me the average age of the person or of people by job. So in this case, the average accountant is 45 years old, the average programmer is 55 years old. And I can also do the same thing with max. What is the oldest accountant and the oldest programmer? In this case, 4580. What's the youngest one with minimum? In this case, 4530. So these are aggregation functions that we can apply onto individual columns. I can also combine this with count asterisk, so I can add as many of those as I want. In this case, I'm just grouping by job, and I'm saying, okay, give me these values based or grouped by jobs. So we're collapsing all the people that have the job accountant, all the people that have the job programmer, and then we have the minimum age and the count here, so the number of people. What I can also do, and for this maybe we should craft more examples like this. So let me maybe add, by the way, we can also do this in separate rows. So let's do this like this so we have a better overview. I can now go ahead and just copy this, just so we have some more data, and then we could have maybe people with the same age. Let's say John Stones, or actually let's give him John Smith, 80, and also programmer, so they have the same age and occupation but different names. Then we could say Susan, also Smith, let's say, and she's 32, and an accountant. And then we could go with Bob, I don't know, Gates or something, and he is also 32, and he's, let's say, a designer. Now let's truncate the table again, run the insert statement, and of course, don't forget the commas here, then run the insert statement. And now if I do that, first of all, we get more data to look at, as you can see. But now what we can also do is we can group by multiple columns. So I cannot just say group by job, I can say group by job and then group by age. So I can run this and I would get the combination. And for this, I should also provide age here as a column that I'm selecting. But you would see now that, and of course now the minimum age doesn't make a lot of sense. So let's go just with count. This would show us that we have one accountant that is 32. We have one accountant that is 45. We have one programmer that's 30. We have two programmers that are 80. And we have one designer that is 32. Now I can also group by last name if I want to. So I can say last name, and the column here is also last name. Run this, and you would see that I have two programmers with the name Smith. And then for these, I could also get the average age. So that would make sense in this case to see the average programmer with the last name Smith is 55 years old. And there's also a special statement that we can add at the end of this to have a condition. So for example, give me the job, last name, average age from people, grouped by job and last name, considering, the condition is that they have at least a count of 2. So that the count of asterisk has to be greater than 1. In this case, we would only get those where it actually makes sense. This would just be a single row, programmer, Smith, 55, 2. And by the way, if you don't like the way this is displayed, like average or count, you can also go ahead and give it an alias. You can just go select job, last name, average, and then you can say as average age, and then count as whatever, like number of people or something like this. So I can just run this, and in the output, I would get different column names. And then one more thing before we move on to the next category of commands. One simple thing that we can also do is we can limit the amount of rows that we get back. So if I do something simple like select everything from people, just run this. This will give me all the rows, and I can also limit that if I want to. I can say give me all the people, but give me a limit of 3, which of course makes sense with the ordering. So if I do it like this, it makes also sense.
Il n'y a pas juste les exprès. Ça pourrait être intéressant. Ouais, je pense qu'on pourrait faire l'exercice parce qu'on a déjà tout regardé du tout. Yes, c'est pareil. Ça, on n'a pas besoin de tuto, ça c'est plus ou moins en avançant. Ouais, je fais l'exercice, ça serait mieux. Ça serait bien. Puis, ok, alors, on save ceci. Puis, on ferme. Bon, je vais supprimer ça. Ok, par la suite, on va juste... Allez, super, très beau. Puis, on va disappear. To get access to today's open DXS stick. Distribution trade also, ok, that's it there. Je pense que c'est juste utile basique. Ce qui va poser avec. Ok. Ça c'est quoi? Et tu me bases en IT, sequential, ok, basic address information. Ok. Bon, cette vidéo était cool, mais disons, ça c'est cool de finir, mais j'ai fini parce que j'aime mes tutos. On va juste faire les exercices et puis c'est ça. Ah, c'est un peu SQL Queries. Bon, ça peut aimer là. Ça, peut-être, ça va faire l'affaire. Et puis, ça va des erreurs. Ici, create, create table. Bon, là on a un problème. On va juste. C'est ça. Parce que là, c'est en fait de choisir un truc. Dans l'employement directement. Schéma CD 200 existe. Comment ça? Je pense qu'il y a quelque chose. Non, c'est vrai. C'est parce que. Ça. Attends, on va citer. On doit effacer. Ouais, je pense que c'est correct. Les tables sont créées. Et puis on va juste mettre ça veut dire. Tables. Ok. Ah, c'est juste pour les tables, juste pour les queries et tout. Donc, on peut commencer. On va juste analyser les questions et puis. Voilà, ça peut commencer. Hmm. Je vais mettre ça comme ça. Question dit. Okay, just all the information from the CD information table. Ok. Ça c'est select. facilities. Puis on dit run. C'est du save. Ok. Et ça explique même. Ouais, c'est intéressant. Ok. Ça peut être intéressant. En même temps, je veux aussi c'est ce que je fais, mais disons, je n'ai pas fait les deux en même temps. On va plus ou moins faire, puis avancer. En avançant, on va juste écrire une partie Unix, c'est le basic. Ok. You want to print out the list of all of the facilities and their costs. To remember que of the privileges of only facility members. Ok, ça serait celle-là. On va faire select. SQL. Oh, c'est pas. Sont des, je sais pas. C'est dans le machin. Dans Cities, même machin, facilite, même backers, même des mêmes, machin. Ouais, même backers, machin, facilite euh, dash affirme, machin, facilite church et feed, machin truc. Ok, c'est ça. Et puis on défi ici. Less than one. C'est lorsqu'on dit one feed, attends, sont calculatrices. Là c'est 35. Oh, c'est vrai, j'ai pas les données. C'est vrai que mon query doit fonctionner. Ok. Ok. C'est que j'ai. Parce que mais c'est ça que j'ai fait. Pourquoi ça dit que c'est pas ça? Parce que c'est 1 divided by 50 times la valeur. Mais là, c'est ça que je fais. 1 divisé par 50 fois la valeur. Mais là, ça ne donne pas. Ok, c'est que soit je fais un truc mal ou bien. Parce qu'il dit one fit of the monthly maintenance. Ça, c'est le monthly maintenance. Ouais, c'est ça, one fit of the value, divide the value by 50. Bon, c'est un peu comme si je fais one. Ok, bon, je vois. C'est vrai que j'ai fait un, ça divisé par ça veut dire que je pourrais même peut-être faire ici. C'est vrai que ça va toujours venir, mais je sais pas trop si la réponse va sortir. Ok, c'est mal bête. C'est quoi la différence entre 1 divided by 50 times la valeur? C'est bizarre. Ok, moi je mets une playlist qui serait intéressante pour éviter. Travail. Ok. Ok. Non, c'est ça, en fait, c'est juste parce que ça dit one fit. Bon, tu utilises pas la valeur. C'est bien ça, mais je suis parti sur one. Tu vas dire, je sais pas pourquoi ça n'a pas considéré que c'est la même chose. Selon moi, c'était la même chose. Ok, je suis un peu curieux. Intéressant. Raison se regarder en fait. Bon, ça se regarde dans le cast storage. Ok. Bon. Ok. Senti. How can you produce a list of all facilities with the web function engine? Ok, si je veux faire select. Tu peux- Et sans utiliser le or. Ok, est-ce que je peux faire ça sans utiliser le or? Try to do it without using the or operator. Parce que moi, j'étais en train de faire ça. Était or. Bon, c'est vrai que c'est plus facile. Désolé. Tellement, voyons voir, est-ce que tu peux faire ça autrement? Ouais, facilities. Je pense, ouais. Je pense pas. Comment ça? J'ai besoin de valeurs. Comment ça, je peux utiliser le or? Voyons voir. Processus, ouais. Ça va directement sortir le truc. Mais ils ont dit try to load machine. Ah, ok. Ouais, c'est vrai. Ouais, ah ouais, je vois ça. Là, je pourrais faire ça. Puis je fais in. Là, je fais 1 et je fais 5. Si je fais un run, ça va toujours donner la même chose. Ah ouais, c'est ça. C'est vrai, j'ai pas pensé à in. C'est-à-dire facile in ça. Puis tu peux utiliser, je sais pas si on fait un commentaire ici. Tu peux faire. Je vais copier ça, je fais. Dans l'autre est facile. Moi, désolé pour le in. Bon, c'est vrai, le in fait son travail. Ça déjà, je sais pas trop pourquoi faire ici. Ok, je vois. Bon, ici on dit, how can you provide a list of facilities with each levels to select name du maintenance form. facile. Ouais. Ouais. Which label as machine truc depending on if the Monday comes is more than machine. J'ai jamais fait ça. Il y a un truc, c'est plutôt, c'est quelque chose que je vais pas faire. C'est intéressant de voir le résultat. Parce que là, ils essayent de faire en mode dépendamment de la valeur. C'est un peu comme si ça te demande de faire un ternary operation, c'est-à-dire, voilà le monthly cost. Ouais, je prends le nom. Monthly cost, c'est ce que tu as dans. Si c'est que tu as dans ça, ça doit te sortir expensive. Else, ça te sort que c'est cheap. C'est pour ça que ça veut faire, mais c'est ce que je fais ça en SQL. Je sais pas si j'ai déjà fait. Donc, je pense. Ok, c'est ça parce que là, je cherche. C'est classifié, ça c'est Power, c'est ça. Qu'est-ce qu'ils vont demain utiliser? Try look up the SQL key statement. Ok, ouais, je vois ça. Ok, c'est ça. C'est la première fois que j'utilisais ça. En fait, je voyais tout ça, je sautais en fait. Euh, donc c'est un peu ça, ils veulent que je fasse ça, que je fasse ça. Ok, bon, donc c'est un peu ça le ternary, mais avec ouais. La syntaxe c'est kiss, il n'y a rien, il n'y a pas de. J'ai vu ça. La première fois que j'utilise ça, j'ai toujours négligé ça. Puis maintenant, qu'est-ce qu'on fait? Ok. La syntaxe c'est un peu bizarre. C'est bizarre que ça n'est outline pas les trucs. La couleur du change pas bon. Ouais. Ça, c'est déjà que c'est un ternary qu'on va utiliser. Si j'ai un truc qui se crée dans then, on va mettre expensive. Tiens, on va faire un else. Else, on met la valeur. Ok. Donc, c'est à la fin qu'on met le nom de la table. Ok. Dans la syntaxe, si tu sélectes, tu mets les champs que tu veux, tu précises le champ et qui, la condition. Et si je fais, ça va donner, ça va ajouter price. Mais ça va ajouter ça. Ok. Qu'est-ce que je voulais mettre? Je voulais enlever ça. Mais ça à la fin. Ok. Bon, ça veut dire, on va aller aussi ici. Est-ce qu'il y a un commande? C'est un peu ça. C'est juste que la syntaxe, je suis pas à l'aise encore avec cette syntaxe. Et c'est la première fois que j'applique ceci. Donc, ce serait un select name qui va prendre le nom. Ça serait ça. Et où est-ce que ça donne? Bon, du premier coup. Bon, pas du premier coup, mais là, j'ai eu la documentation. Bon, c'est plus ça, c'était plus ou moins. Ça veut dire, si tu veux ajouter, tu veux personnaliser l'affichage, tu vas utiliser le case, puis when, tu mets la condition, et puis maintenant, tu mets le résultat. Ok. C'est quand même intéressant. C'est vrai que j'avais jamais pris le temps de regarder la syntaxe de cette partie, mais bon. Ok, les dates. Du coup, how can you provide a list of members who join after the start of return the chair? C'est pas travailler les dates. Ok. Juste mettre select. List of members who join. Bon, je sais pas si. Bon, la date. Comment travailler les dates? Ici, ça dit quoi? Look at the timestamp format and remember that we can compare that much like. Ça, c'est le timestamp, mais je sais pas. Est-ce que je vais mettre ça comme. Ah, ok. Je vais juste utiliser. Where septembre. Là, je vais juste mettre 0, 0, 0, 0, 0. Ça marche. Je pensais pas que ça devait fonctionner. Mais ça marche. C'est ce que je pensais qu'il y avait une autre condition petit bon pour les dates en fait. Mais là c'est bon parce qu'ils ont dit des stats of septembre donc ça c'est plus ou moins le début, ça c'est toujours le premier jour du mois et puis ça c'est toujours à minuit. C'est ça qui commence le début du mois. Parlant de ça, nous sommes déjà en juillet. Ah, je pense que juste ça serait un petit live. Comme ça, demain, on va pas trop perdre de temps sur. Ok. Bon, peut-être juste ça serait pas un long live. On a déjà fait une 30. Ça pourrait être plus ou moins ça. C'est si, disons, je vais plus ou moins faire de temps en temps, ça va m'étendre, mais c'est un peu ça. On va peut-être continuer cette aventure un jour. Je sais pas trop. Parce que mon but, c'est plus ou moins commencer la connexion entre le code, entre SQL et Java. Donc, c'est un peu ça. Le reste, on va apprendre en avançant. On va pas trop tomber sur la théorie. Donc, c'est un peu ça. Et je dirais que ça serait tout. J'aurais voulu continuer, mais je dois faire quelque chose. Donc, ça serait plus ou moins ça. On va se dire à la prochaine. Ouais, on va se dire à la prochaine. Et puis, ça reste toujours intéressant pour ceux qui en ont besoin. Je vais balancer le lien. Donc, c'est ça. C'est tout pour aujourd'hui. Aujourd'hui, c'était un petit live. Et puis, demain, on va directement tomber sur Java. Et puis, connecter le back, pas le backend, mais la base de données avec Java, avec le code Java. On va commencer demain en regardant quelques tutoriels. Donc, c'est ça. On s'est dit. On s'est dit à la prochaine. Hello. I was searching green. The stream is ending today. Now, see you next time. Like maybe yes tomorrow for another one. Because today was just simple SQL practice with Postgres, but Postgres is the same like SQL, so I'm not too much focus on it. So just directly fall on the connection between Java code on MySQL, en database in fact. Donc c'est un peu ça, donc on s'est dit à demain pour un autre live. Donc demain ça serait la programmation. Et SQL, je ne vais pas trop en fond sur SQL parce que j'ai fait une session complète sur SQL. J'ai appris ma SQL. Je dis pas que je suis pas un pro, mais je ne vais pas reprendre ce que j'ai déjà appris. Donc, c'est un peu ça. On voulait juste rafraîchir la mémoire. On connaît déjà comment la plupart des fonctions travaillent. Donc, c'est ça. On va se dire à demain. Et demain, on va travailler plus ou moins 3 heures de live, j'espère. Ça va dépendre du mois. Donc, c'est ça. Et merci d'être passé. Et merci pour le follow. On s'est dit. Je sais pas si je peux retirer, mais bon. On se dit à la prochaine pour une autre live.